Right. Good afternoon. So the objective is to finish tutorial 1 if possible. Okay, but no need to rush. So question 1, just solving and deciding which one is inconsistent. So inconsistent means no solutions. Do I need to go through? Like which one? I'll go through one, maybe C, right? Is that right? Okay, B is pretty obvious. Okay, so this one, part A will be unique solution, solve easily. Then part B, right? You can observe that actually the second equation coefficients, but the right hand side not differing by the same constant factor. Okay, so which means that the gradient between the gradient of the two lines are equivalent, but y-intercept not the same. So therefore the lines are parallel and therefore not intersecting. Okay, so if you try to solve this, right, you'll get inconsistent. So maybe I'll do part C together with you. Yeah, so you do have to be careful with this because you can observe that the variables are jumbled up. Okay, so just be careful with that, right? So if you were to convert it into a matrix form, then you can observe that the first equation is going to give you the coefficients 1, 1, 1. Then the second one, be very careful here because it's u, v, w, right? So maybe just to be safe, we write down the vector first, u, v, w. There's no need to put it in this order, right? You can put it in any order, like v, u, w, w, u, v, and whatnot, right? But it's just that it must be the same amongst all three equations. Okay, so if you have u, v, w for the first equation, then it applies to be the same for the second and third equation as well. Okay, because that's how you multiply out the matrix to get the three equations shown here. So you can see that this will be a 0, 5, and then the constant here is 6, right? So therefore, for the second equation, right, u, v, w in that order will be 1, 4, 1. Okay, then the last one will be, you can see that is u, which is 1, v is 3, and w is 1. So therefore, this will be your matrix equation with the matrix A shown here. So in order to solve this, is that right? So therefore, in order to solve this using your Gauss-Jordan elimination, then what you can do, right, is just write down the augmented matrix. Okay, so A slash B, the matrix. So this is going to be that 1, 4, 1, 1, 1, 1, 4, 1, and 1, 3, 1, then slash 0, 5, 6. Okay, so now you perform your row operations. So as mentioned, it's good that you have a leading one, right, in the first column. Okay, that will make it easy. So therefore, if you do row 2 minus row 1 and row 3 minus row 1, you'll be able to make 2 zeros here. Okay, because recall that you're trying to get the lower triangle of zeros. So hence, if you do that, you'll observe that you get 2 zeros here, and then this will be 4 minus 1, which is giving me a 3. 1 minus 1 is 0. 5 minus 0 is 5. Then 3 minus 1 is 2. 1 minus 1 is 0. And then 6 minus 0 will be 6. Okay? So incidentally, you got 2 zeros at the last column, right? But it's okay, right? Don't panic. So therefore, from here, right, just try to follow the procedure and make 0 at this 2 here. Okay? This one you want to make 0. So in order to make 0 on that element, right, you can just use your row 2. Okay? So for example, from here you can do a row 2 minus. Okay, so by the way, you might observe that this is a 3 here, right? So one way is what we have demonstrated in the lecture. You divide row 2 by 3 first before you perform the row ops on row 3. Okay, that's one way. But there's actually a kind of a shortcut lah. Okay, the shortcut is, right, just multiply by a ratio to row 2. Okay, so you can see you want, because it's a 2 what? 2y what? So you want this to be a 2y. So what do? 2 over 3 times row 2. Okay, because row operations, you just multiply by some constant, okay, to each row and then take the difference. For example, right? There's no need to strictly multiply by an integer. You want to multiply by an integer, can okay? But you take one more operation, right, on row 2, that is dividing by 3. Okay, so you can see if I do this, effectively I am dividing by 3 and then I take the difference. So I combine 2 row operations into 1, okay, which is perfectly fine. Oh, sorry, this should be row 3, my bad. This should be row 3. Sorry? Exactly. That's also a good way to indicate that this set of equations is inconsistent. Okay, because you can see that 3y equals to 5, so y equals to 5 over 3. But at the same time, y equals to 6 over 2, which is 3. So y is holding 2 values, yes? Okay. So obviously I made a mistake, right? So this should be 6, Thanks for pointing that out. My bad. Okay, so this will be a 6, okay? Okay, so I will get, yes, because that depends on what's the question.
You just say solve.
Okay.
Still
Yeah.
can.
So another question is, can you solve it another way, like substitution, right, and whatnot, or maybe a combination of substitution and elimination? Okay, if the question never states, actually you can. Okay, unless the question states that I use Gauss-Jordan elimination, for example, right, then you have to strictly follow the method being demonstrated here. Okay, so therefore, coming back to the question, right, so we are going to have a 0 here, okay, because we are going to get 2y here, right, or 2v here. Can okay, so because this is a 0, right, then this clearly will be a 0. Then if you observe, this will be what? 6 minus 10 over 3, correct or not? Because 5 times 2/3, right? So it's actually 10 over 3. So if you have 6 minus 10 over 3, which is some constant, okay? So 6 minus 10 over 3. So 10 over 3 is what? 10 over 3 is 3.5, right? So which means that you're getting 2 and 5, 6. Yes? This one will be 6. Wrong, Oh, okay. Yeah, so I forgot to update this, updated this, forgot to update this. Thanks. Okay, so therefore this will be what? This will be 5 minus 6 minus 1, right? 6 minus 6 is 0. Is that correct? Oh, wait. This will be 5 and 6. Correct, right? Yeah, correct. And this guy will be minus 1 and 0. Okay? Yep. So therefore this guy will be a minus 1. And hence this will be what? Minus 2/3. So therefore this will be a minus 4. Oh, no. This cannot be a minus 4. It should be 2/3 times minus 1. So it's actually 2/3. Okay, so it's 0 minus 2/3. Agree, 0 minus 2/3. So this should be 2/3. Okay? Yes, so which means that from here you can argue that your system is inconsistent. Okay, because the very last row, right, you get 0 equals to 2/3. Okay, which is actually false. So therefore, inconsistent. Okay, no solution. Any questions? Okay, good. So therefore, I'll leave the first 2 parts of question 1 to you. Okay, so this one you DIY and this one DIY. So question 1 done. Question 2, do I need to do any of them? Matrix multiplication and just transpose. Okay, so no need, this one you DIY for A to I and then check against the answers given. Question 3, do I need to do? So question 3 is a bit on math modeling because they give you some word problem and then you're supposed to form the equations and then solve for the unknown, unknown salaries. No need? Okay, good, DIY. Question 4. Well, question 4 just repeat the row operations that we have demonstrated in question 1. Just that in this case you will get a unique solution. No need, Number 5. Question 5. Question 5, do I need to do? B, So question 5, I would like to maybe do a bit of a swap. Okay. Why is that so? Because I see that I have a 1, 1, 1 here, right, in the second equation. So therefore, I can actually just swap with the first row. Okay, so if I swap, then I write this in matrix notation, right? Actually, don't even need to write matrix notation. Straight away write the augmented matrix. Okay, so augmented matrix, right, is 1, 1, 1, then 2. Then you can see that if I swap, then that will be a 3 minus 4, 0, and then 8. And finally, you have 2 minus 5 minus 1 and 6. Any questions? Okay, so usually I like to have a 1 here, right? If I don't have a 1 here, can do or not? Can do lah, but you have to do the fractional multiple. Okay, like this is a 3 ma, right? So just now I mentioned that, of course, you can divide throughout by 3 first, then make this a 1. Then you just take row 3 minus 2, row 2. Okay, but you need one extra row ops, what? Correct or not? So in order to avoid that, if I see a 1 here, right, then I will just try to put it at the first row. Okay, actually that's not a strict must. Some people can work with the 1 in the second row. Because row operation, actually, you don't need to use row 1. Okay, you can use row 2. What? Right? So if it's possible that if you leave the 1, 1, 1 at the second row, you can actually do row 1 minus row 2. Okay, or row 1 minus 3, row 2, for example. So it's up to your flexibility. I'm just trying to make it blatantly obvious so that it's easier to recognize the pattern. So clearly this will be giving me row 2 minus 3, row 1. Then after that, row 3 minus 2, row 1. So hence you get the 2 zeros at the first column. And then just have minus 4, minus 3, minus 7, then minus 3, and then this is a 2, minus 5, minus 2, minus 7, then 1 minus 3, then this guy is 6 minus 4. This will be 2, right? Okay, so at this juncture, it's pretty clear that the second equation, which is this, is equivalent to this. So therefore, if we just do one more step just to make it clear, which is row 3 minus row 2, then you're going to get a 1 complete row of zeros then. So the net result is actually you got only 2 equations, or only 2 independent equations. So you can make a conclusion then. Okay, so 1 full row of zeros. So that means only 2 linearly independent equations. Then you have 3 unknowns. So what does that mean? That means that you have infinite solutions. Okay, so that means your system here is not linearly independent. So SLE is not linearly independent and consistent with infinite solutions. Okay, so what is the rank? Rank is 2 lah, because you got one equation, second equation. So rank is 2. And then now from the second row, you can solve for the unknown. Okay, so from the second row, you can write minus 7y minus 3z equals to 2. Okay. So, okay, let me see what my answer isolates. Okay, my answer actually isolated z again. So maybe I'll just isolate z. So that means from here, right, I can have z equals to, so you'll be dividing by 3. So hence it will be minus 7y minus 2 divided by 3. Okay, so this will be one form. Sorry, not one form. One portion of the equation. Then the second equation. So the second equation, right, will be x plus y plus z equals to 2. So once again, we want to get rid of the y. Okay, so since we want to get rid of the y, we can just take, we do some row operations. Okay, so therefore, you can see that we just make a 7 row 1, because this one is row 1. 7 row 1 minus, or rather plus, row 2. Okay, you can actually do it here if you want to, right? So this is going to give us, so you can see that 7 row 1 is going to give me 7x. Okay, so this is my row 1. This one is row 1. Okay, this is my row 2. So 7 row 1 minus row 2. So I'm going to get 7x plus 0y. Then after that, I have 7z minus 3z, right? So I'm going to get plus 4z. So therefore, this is equivalent to 14 plus 2. So that 16, right? So that means the isolating of z is going to give you, so it's going to give you minus 7 over 4x plus 16 over 4, which is 4. So the solution, so-called the infinite solution, is z equals to this equals to this. Is that right? So two planes, they will intersect at a line. Okay? So therefore, the solution is actually a line of intersection. Any objections? Okay, one thing to take note is that if you were to just eyeball the equations here, it's not easy to tell that actually one of the equation is a linear combination of the other two. It is, because you have one row of zeros here. So effectively, there's just two unique planes, two independent planes. Okay? One of the planes here is achieved by a linear combination of another, of the other two planes. But, I mean, I can't tell lah. Yeah, I can't really tell. Yeah, like which one multiplied by a constant plus which one multiplied by another constant, right, equals to the other one. I mean, if you ask me, I can't really tell. Okay, but the row operations will tell you. Is that all right? Any questions? Can? Right, so this will be for question 5B. So 5A you will DIY because it's unique solution, no problem, I hope. So question 6. Question 6 is also something like a modeling problem, although a more straightforward one. Right? Do I need to go through? Okay, so the story here is, right, you have a quadratic function used to model the displacement time function of an object being dropped from some tower. So given the data below, define the quadratic function. Okay? So I think in your physics, in year 1, I mean you are still at year 1 now, right? Okay, I mean 2 trimesters ago, you might have noticed that if you neglect air resistance, then the path that an object takes is governed by the parabolic function. So parabolic or parabola means quadratic function. Okay, so what is a quadratic function in case you have forgotten? So this quadratic function is just s of t, for example. So this is a displacement function, displacement time function. That is equivalent to at square plus bt plus c. So that's a quadratic function. Okay? Yeah, in fact, if your object is dense enough, okay, and the air resistance is small enough, let's say you have a very dense aerodynamic object such as a sphere, right, then actually this function is pretty accurate at describing the motion of that object. Okay? So hence, we want to find out what is the A, B, and C's. Okay, we want to get A, B, C. So in order to get A, B, C, obviously you need 3 equations to solve 3 unknowns, what? So that's the story. So in order to solve for the A, B, C's, you have the data points here. So you have the first data point. So the first data point is going to give you one row, right? S at t equals to 0 equals to 0, right? Oh, sorry, equals to 100. Okay, but you sub in. So you really get C equals to 100. Because it's A times 0 square plus B times 0 plus C. So therefore the answer is C equals to 100. So you found the first unknown. Don't even need to solve anything. Then you just repeat for the second column. So for the second column you get what? S of 2. So that means at time t equals to 2, you are going to get 4a. 4a plus 2b equals plus 100 equals to 84. Because C is already 100. So that means the second equation will give you, so this guy is going to be 100 minus 84, so that gives what? 16, right? So 16 divided by 2, you're going to get 8, right? So you're going to get a 2a plus b equals to 8. So then your third equation, last one, from the last column, so that's going to give you s at 4. So hence you're going to get 16a plus 4b, then plus 100. So that's going to be 36. So 100 minus 36 is 64, right? 64 divided by 4. So I'm going to get 4a plus b. 64 divided by 4 is 14. Is that correct? No? 16, you're right. Goes to 16. Minus my bad. So this guy should be minus 8 and minus 16. Okay? So therefore you got two equations, two unknowns a and b. You solve and you get a equals to minus 4 and then b equals to 0. Okay? So your c is 100. So hence you can get the answers. So from here, once you have the function fully defined, then it says how long does it take for the object to reach the ground. So basically you have your s of t equals to minus 4t squared plus 100 equals to 0. Okay, so you just solve for t, you get t equals to 5. Any objections? Okay, so just give you a sneak preview. The problem here gave you the condition that you got 3 unknowns, 3 data points. So 3 unknowns, 3 data points, just right. Okay, can solve for unique solution ABC, right? So then you know that if I only have 2 data points, then it's not sufficient to solve for ABC. Okay, 2 equations, how to solve 3 unknowns, right? I mean, can solve. You get infinite solutions. Okay, which means that your solution is not fully defined. What about 4 data points? If you have 4 data points, right, because I can do experiment, right? Because when I do experiment, okay, I take 3 points here, right? But I can do experiment, that means I take more points because I want my ABC to be more accurate. Possible what? It has to match more points, correct or not? So therefore, the story is if I have more points, more data points, then I have an overly constrained problem. That means I have many equations but only 3 unknowns. Many equations with only 3 unknowns. Okay? So the solution for that is an optimization problem. Okay? Which means that I'm trying to fit A, B, and C as close as possible. Right? I won't be able to fit all data points exactly, but I can fit all data points as close as possible with the minimum error. Okay? So that is called predictive modeling. You have many, many data points, right? You want your function, you want your predictive function, right? This is your predictive function to fit those points as accurately as possible. Can Okay? So we're going to cover that in Math 3, how to fit those points. So Math 3, come back to the linear algebra thing again. Okay? Of course, at a more interesting application level. So question 7. Do I need to do question 7? 2 acid solutions, then after that mix together, you need to get the 40 cm cube of 3.2% acid solution. No need, Do I need to do? Yes? Okay. Yeah, so question 7, hopefully you have tried already. So your 2 acid solutions, right? One is 2% by volume, the other one is 7% by volume. Okay, so what that means is, acid, right? Okay, so when it's a certain kind of acid, then usually you have to mix it with water. Okay, so one is 2% is acid then actually the 98% is just water. Okay, or some solution. So therefore, the other one is 7%. So now I need to get 40 cm cube and 3.2% acid solution. Okay, so how many cubic meters of each acid solution should I mix? So how you model this is how many cubic meters of each, correct or not? So therefore, you just define. So to find volume of each. So say x and y, okay? So x and y, right? So x is the 2% one, let's say lah. Then the y is the 7% one. I mean, it doesn't matter which is which. Okay, so I just label x for the 2%, y to be the 7%. Can? Okay, so once I have that right, then I have to find my constraints, what? Correct or not? So these are my unknowns to solve for. So two unknowns, x and y. So then I need to have my constraints. So the first constraint must be what? First constraint is that I need 40 cm cube, what? So 40 cm cube is the first constraint. Then obviously I need 40 cm cube, means x plus y must be equivalent to 40 cm cube. So let's take it that the unit here is cm cube. So this will be my first equation. Okay, because this is volume of each, right, x and y, and this is already in cm cube. So then the second equation is what? Second equation must be 3.2%. Okay, so because it's by volume, the percentage is by volume. So therefore you can straight away use the percentage values directly. So the first one is 0.02 times x, because it's 0.02%, 0.02 proportion, right, which is 2% of the volume x, okay, plus 0.07 of the volume y, okay, that must fulfill 0.032, okay, of what? Of x plus y. Because that's the total volume. It must be always of the volume, the percentage of the volume. Any objections? So if you interpret this wrongly, then of course you cannot solve for the answers. Okay, so basically this one just multiply by 100 and then just take the difference. So just check for me. So here is 0.02, 0.032, so 0.032x, right? So it will be minus 0.012. Then after that, I'm going to get 12x, or rather minus 12x plus, so this is 0.07 minus 0.032, so I will get 0.038, then it will be 38y. Is that right? Equals to 0. So obviously I'm going to get dividing by 4. Can I divide by 4? No, divide by 2. So I should get minus 6x plus divide by 2, 19, right? Is this legit? Did I do the math wrongly? 6x plus 19y equals to 0, correct or not? Can someone check for me? Is that correct? Thanks. Okay? Yep. Right, so you got one equation, two equations, solve to get the solution here. Yes? This one okay, so because this one is 0.032x if I bring across, right, then become minus 0.012, right, times 1,000, then become minus 12. Okay? Hopefully I didn't make mistake. Right, so that'll be for question 7. Okay? Okay, next what? Next problem. Winning a boss fight in a game. Okay, so in this MMORPG, right, which stands for multiplayer, what's the other M? Okay, I cannot forget what's the MMO representing, but I know RPG is role-playing game. Okay, yeah, there are 3 items that you can equip to increase your attack, defense, and dexterity points. And the number of each item you can equip X, Y, Z respectively. Yeah. Okay, so you got 3 items now. Let's say, right? Dragon Scale, Griffin Claw, and Elven Crystal, X, Y, Z respectively. Right, so if you equip the Dragon Scale, so if you equip 1 Dragon Scale, right, your attack minus 20. Okay? Why? Because maybe you put on the Dragon Scale a bit heavy lah, so then your attack become less forceful. But then the defense up by 40 points. Okay? Then the dexterity up by 10 points. Okay, assuming according to the thing here. Right, so Griffin Claw is a certain attributes here, and then Elven Crystal is another set of attributes here. Okay, so in order to clear the boss, the level boss, you need to increase your attack by 320 points and defense by 280 points. So if the number of items you can equip is 16, cannot equip like forever ma, okay? So show that the problem gives the system in matrix form given here. So this is an example of what you will get in your midterms, okay? When I say example means like part A, I ask you to show the system that you will get. Okay, so from here to here is mathematical modeling. If you cannot get, then you just lose the marks for part A. Okay, part B is solving. Can So at least you should be able to solve even when you cannot do the modeling. Okay, so how do you get the equations there? I think this is quite similar to the farmer's problem encountered in the lecture. Okay, it really doesn't matter what is the story behind. You are looking for two things: variables to solve and constraints. Okay, you just look for these two things. The variables to solve, very straightforward, x, y, z, label for you already. Then the constraints must be given by the story in the problem. So you need to increase your attack by 320 points. But then attack is this one, right? Right not? So that means the first equation should be, so if you look at the attack points, attack requirement, you will have minus 20 times x plus 50 times y plus 10 times z. Then the attack points you need is 320. So this will be your first row. So next up will be your defense. Okay, because they also say that you have to up your defense by 280 points. So that will give you your second row. 50x plus 10y plus 10z equals to minus 10. Obviously not. Equals to 280. So that's your second row. Oh, 40, not 50. Okay, then you notice that there's no requirement on dexterity, what? Correct not? No requirement on dexterity. I only need to have attack points and defense points up only in order to clear the boss. Okay? So where is the third constraint? The third constraint must be the total number of items that you can equip, what? So this will be the third constraint. So therefore, total items. So this has to be x plus y plus z equals to 16. Okay? So therefore, you can observe that if you take row 1 divide by 10, you are going to get this row 1. Similarly, row 2 divide by 10, you will get this row 2. And then row 3 will be as is. How about that? Okay, so this is your SLE, your system of linear equations in matrix form. So that's for part A. Okay, any questions? Okay, if not, B, DIY. So this one just solve linear equations, that's all, using row ops. You get unique solution, 4, 7, and 5 respectively. Okay, So let's look at question 9. Let me see. Okay, question 9. So we're only left with 9 and 10. Okay, so question 9 has two parts. Okay, maybe I should let you have some time to try the question, especially in the modeling part first. So part A is modeling. Right, so this one is you are trying to create your investment portfolio. Okay, so you have $12,000, right? Invest into 2 bonds and a mutual fund. Okay, so mutual fund is like some professionally so-called managed fund. Okay, then they go and buy stocks, buy bonds and whatnot, right? So that they return you a certain percentage every year. Usually is projected. Okay, so you can see there are 2 bonds, right? You know what are bonds, right? So you buy the bond, then you get the coupon payment. That means you get the interest payment. So you are like the lender. Okay? Although most of us, we are borrowers, we are borrowing money from the bank, let's say to service your student debt or your house debt, etc. Okay? But in this case, you buy a bond means that you lend, right? You are lending to someone. Okay? So then like, for example, you lend the bank, right? Then the bank go and invest, make money, and then the bank will return you your so-called interest. So then there are 2 bonds. Higher risk bond A pays 5%. Lower risk bond B pays 3%. Okay? So of course, high risk, pay more lah. Then the mutual fund is a stock fund. Okay, invest in a lot of stocks. Then projected to return 8%. Okay, of course projected lah, right? Because cannot guarantee the stocks are very volatile. So this is your condition. Okay, this is your condition. Because you have 12,000, you want the annual return to be 700. Okay, $700 for the whole year, for 1 year, right? And then because you're a bit, risk adverse, so you want the bond investments to be twice that for the fund investment. Okay, because stocks more volatile, more risky. Okay, so therefore you want to invest more in the bond. At the end of the bond tenure, right, you get back your principal. Okay, so you're supposed to define linear system, do the mathematical modeling, and create the system of linear equations. Okay, understand the problem here. So this one quite quite common. Okay, for people like us as well as investment managers. So of course now we do the most important thing, which is mark attendance. Alexander, Aliyah, Emelina, Angelico, Brian, Chen Chang, Zhen Yi, Ivan Chow, Yang Ying, Emilia, Erwin, Yan Jin, Zhan Yang, Dongbing, Noritetsu, Xavier, Joey, Jordan, Kayla, Kevin, Ken Leong not here, Sharon, okay, Dawson, Chen Ying, Dawson is present, right? Jonathan, Kun Yong, Mac, Nikhil, Mohan, Azari, Danish, no? Irfan, Naya not here. Bing Jie, King Hong, Zixuan, Fadila, Phoebe, Yan Heng, Sherwin, Raymond, Benjamin, Raymond no, Reese Tan, Sorawit. Your name is Sorawit or Rijiratana Lai? Sorawit, Jumpang, Jerome, Sean Brian not here. Justin, Hao Po, correct, right? Ryan, Sohadi, Johans, Wei Yan, Yi Zhong, Tiamzhen, Trisha, Hong Tan, Shi Kang, Xing Zhi, Zotet, Pin Wai, Zun Pin Wai. Right. So I think we go through. So similar to earlier modeling problems. First of all, you need to define the unknowns. So the unknowns here is that how much should you allocate, right, to each investment vehicle. So the allocation to each investment is your unknown. Okay. So maybe you can let say, okay, then you have a bond A, right? So maybe I'll just use ABC, right? So you have an A, which is in the, A, right, will be in low risk bond. Then B is in high risk bond. Then maybe C, right, will be in the fund. Okay? So that means you have three unknowns A, B, C to solve. So having identified the unknowns to solve, you need constraints, you need equations. So constraints will give you your equations. So first constraint, you have $12,000 to invest. Okay, total you have only 12,000, right? So the first constraint clearly is going to give you A plus B plus C equals to 12K. So clearly that's your row 1. Okay, because you don't have more, right? You can only have 12,000 in this case. Secondly, you want the return to be $700. Okay, annual return to be $700. So therefore, this is going to give you your second constraint or equation. So, but how do you get the return? Well, you have to look at the returns for each investment vehicle, right? So bond A is paying 5%. Oops. Apologies. The low should be B. So the high one should be A. Okay, according to this definition here. So therefore, you are going to have 0.05, because it's 5%, of the investment in bond A, then plus 0.03 plus the investment in bond B, then plus 0.08 plus the investment in in fund C, the stock fund. Okay, so that returns, the combination of the returns here is going to be $700 as desired. Okay, $700. So that's the second constraint. Then you need one last constraint because you have three unknowns. Okay, so if you want to solve for the unique allocation amounts, you need one more constraint. So the one more constraint will be total bond investments must be twice of the fund investment. Okay, so that will be a third constraint. So you are going to get what? A plus B, because A plus B will be the total bond investments, must be twice that. So that will be equivalent to 2C. Okay, twice that for the fund investment. Any objections with the interpretation? No? All good? Okay, so certainly once you have your constraints being written down, right, then you should put it in the so-called nicer form. Okay, so you see the second equation, right? You multiply by 100 throughout, you're going to get a nicer equation, which is 5A plus 3B plus 8C. And that is going to give me 700 or 70,000. Okay, so this will be directly your row 1. This will be row 2. Then your A plus B equals to 2C. So certainly you can write it as A plus B minus 2C. So that will be equivalent to 0. So that will be your row 3. So 3 constraints, 3 unknowns, you can have a unique solution potentially. Is that alright? Any objections? Okay, if no, then I won't solve. You should be able to solve on your own. Wait a minute. Oh, okay. So if you were to solve this, right, part A, you will get these solutions. So bond A, you allocate 7,000. Bond B, you allocate 1,000. So therefore, the mutual fund, you're left with 4,000. Okay, so you can see 8,000 at the bonds, which is twice that of the mutual fund, satisfying the constraint, one of the constraints here, row 3. Okay, and then you can see that 8,000 plus 4,000, you get 12,000. So that is also satisfying the first constraint. Okay, and then if you were to calculate this, right, 0.5 times 7,000 plus 0.3 times 1,000 plus 0.05 times the first one, 0.03 times the second one, plus 0.08 times the mutual fund 4,000, you're going to get $700. Okay, so that's how you can check that your solutions are correct. But now, it asked, explain if the answer is logical. Is this logical? What is logical in the first place? What do we mean by logical? Solution DIY lah. Okay? This one can solve. But what do we mean by logical? Anyone wants to try? Yeah lah. That's what I'm trying to say. What do you mean by logical? Yes. Sorry? Okay, it fits all the criteria because you can easily substitute the ABCs, right, into each of the equations and see that they will qualify. That means meaning to say they will equate. Right? ABC equals to 12,000. Right? A plus B minus 2C equals to 0. And you can also check row 2 will be satisfied. So that one mathematically you can check easily. Okay, but I'm asking you, right, the fund, or rather the asset allocation amounts, is it logical or not? Because you must have some feel, ma. Right now, hey, this one, wow, bond A so much, bond B only 1K, then mutual fund 4K. So are the proportions logical or not? Why is it not that bond A actually 1K? Then maybe bond B 10K, that kind of thing. So I'm asking you about, are the relative proportions logical or not? Expected or not? Not logical because the percentage, right? Why is it that it doesn't match? When you say doesn't match, means which part? Yes. Bond A is high risk then? Bond B is low risk. Oh, so you feel that you should put more into bond B, which is lower risk. Okay, but if you put more into bond B, then you earn less, because B is low risk, 3% only what? Correct or not? So are you sure when you invest more into bond B, can you get the $700 desired return or not? Yeah. Any other explanations? Anyone? Okay, so first of all, to answer whether it's logical or not, right, you got to look at what is the percentage return you desire. Okay, so the total return that you desire, total percentage return is what? Is $700 divided by your 12,000. Okay, then of course times 100%. So if you take 7 divided by 120, 7 divide 120. So you get 5.83%, right? Okay. So you observe that actually 5.83% is considerably higher than what bond B can give, right? Correct or not? But it's considerably lower than what the fund can provide, which is 8%. So it's like in between bond B and the mutual fund. Okay? So therefore, bond A, which is 5%, that is close to the total return, the total percentage return desired. So therefore, bond A, right, has a much larger weightage, much larger proportion allocated. Okay, but this is 5% what? But this is 5.83. So therefore, you still need to pull it up a bit. So therefore, you need this $4,000 in the mutual fund. Okay, you need more of the mutual fund to pull up the percentage, because this is 5% only, right? You need the 8% to pull up the 5% so that you can get 5.83, right? But not that much until you allocate more to the mutual fund, okay? But you cannot invest too much in bond B, because if you invest too much in bond B, you cannot get the 5.8% that is desired. Do you understand that? Okay, so the asset allocation amounts must be in agreement with the constraints that you give, okay? So therefore, in this case, this is not entirely unexpected. So from here we can see that the amounts allocated seems logical since the total percentage return is close to bond A, to bond A's return, okay, 5%, and some higher risk, some higher return from the fund, which is 8%, is needed to increase to 5.83%. Okay? So certainly bond B shouldn't be taking too much of your money, right? If you desire that kind of return. Is that all right? The ratio here makes sense. Okay? The ratio here is so-called reasonable. So what I'm trying to say here is that, right, because after you model, then you solve. One way to check the solution, of course, besides substitution and checking everything is equal, right? Now you have to use your logic a bit, okay? So let's say, if, for example, if let's say this one is, let's say 1,000, then this one suddenly become 10,000. Then you have to ask what? Wow, this one 10,000 invest so much, right? Invest so much, then by right, it should be closer to 8%, what? Correct or not? If it's like that, right, my investment return, right, will be, maybe it's about 7 point something percent, okay? Because there's more fund, what? Fund is returning you 8%. So, therefore, this answer cannot be in agreement, right, with the desired percentage total return, what? You understand that? Okay? But this is also trying to ask you, right, after you solve, after you have a so-called desired portfolio, you should question yourself, is this what you are comfortable with or not? Okay, because you must remember this one is projected. I don't know whether your insurance friend or your banker friend got talk to you nicely, showing you some very nice projected returns. Usually the projected returns are fantastic. Okay, but the guaranteed returns are pathetic. Agree, Okay? Yeah, so you have to be careful with those things, because every month you put in money, right? Okay, so let's look at part B, which is also a modification, requiring a modification to your system. So in addition to the conditions above, if you also want the overall annual yield to be 6.5%, define the system of linear equations. What kind of solution can you expect? So inadvertently, I also explained part B already. Because if you also want one more constraint, overall annual yield to be 6.5%, then obviously you need one more equation, what? Correct? Okay? So what's the one more equation? The one more equation is simply, you want the annual yield to be 6.5%, right? So that means the total yield, which is this equation, this part. So you want this to be what? You want this to be 0.065 of 12,000, which is your total investment amount. Agree or not? Correct? This is 6.5%, right? 0.065 of your 12,000. So this is your overall annual yield. Okay? So obviously you can expect that this R4 is going to conflict with what? R2. Okay? It's going to conflict with R2. Because if you calculate this, this is not going to give you 700. It's going to give you maybe 800 plus. Okay? It's not going to give you 700. So what does that mean? That means you got the same coefficients, right? Same coefficients but different y-intercept. Or rather, in this case, right, different intercept. So what does that mean? You got another plane that is parallel to R2. Okay, so the geometry is such that, right, R4, plane that is parallel to R2. So if you have a plane that is parallel to R2 and you have already a unique point of intersection between this R1 to R3, right, then certainly this plane is not going to lie on the unique point of intersection. Understand that, right? Okay, so therefore the truth is no solution. Okay, so therefore what kind of solution can you expect? No solution. So I explain through logic without calculations. No solution, since the unique solution in part A cannot satisfy R4. Any clarifications that you want to make? So part A, already one unique point of intersection, right? Because you got three independent planes. Then now you have a plane that is R2, right? Shifted or offset. That is giving you your R4, your black plane. Then obviously when you offset that plane, it's no longer intersecting with the original solution unique point. So therefore, you cannot satisfy all four equations at the same time. Is that alright? Can? Okay, good. So last question, which is on the partial assessment question. So actually this one is very straightforward. Okay, I'll leave you to DIY. Okay, but the story here is you are just given two planes, P1 and P2 respectively, as you can see, given by the equations. Then you are supposed to evaluate the line of intersection between the two planes and show that it can be written as this. Okay, so what's the deal with this question? The deal is that I don't tell you is that it is just solving of a system of linear equations. Okay, and some of you may be thinking, hey, two equations, how to solve for three unknowns? Can what? Correct or not? It's just that your solution is not unique. Okay, your solution is not unique. So therefore, the solution is very straightforward. Okay, so the approach is really the augmented matrix A/B. It is just equivalent to solving. You have only two equations. 1 minus 1, 1, 2, 3, 3, 1, 8. Okay? Then after that, you just need to perform row operations. So row ops. So in this case, don't worry about the last row of zeros. You have a last row of zeros, right? I mean, if you want to follow the procedure that we have demonstrated. Okay, but you don't really care about the last row of zeros, what? Have or don't have, doesn't matter, ma. You can still work the row ops through the 2 rows here. Okay, so the truth is, eventually, if you make this a 0, maybe just 1 row ops will do, you will be able to solve to get this equation. Okay, so row ops, you will get this. So this part you DIY. Any questions? All right, if you need more practice problems, as usual, please go to the OpenStax websites here. Okay, there are probably too many questions for you to do, right, for you to practice. Okay, so if you have no questions, I will call you a day for our tutorial. And then regarding your quiz 1, so your quiz 1 is on the week after next. Okay? So therefore, quiz 1 will be testing on topics 1 and 2. 1 and 2, because we still got next week. Okay, so next week we will definitely complete topic 2. So which means that your quiz 1, which is on 8th of June, Monday, right? It will be topics 1 and 2. Okay? I'll make announcement on the X site. Right? Sorry, next week. Okay? Next Monday. Right? You'll see the announcement. So you still remember the format for the quiz? Okay. Listen. So for your quiz, it'll be an online quiz, Google Forms. Okay, maybe about 10 questions as usual. Right? You go to the lectorial. Okay, use your laptop. You can use your tablet, but the condition is that your tablet as well as your laptop must be in this inclined manner. Meaning to say you cannot flatten and put it entirely on the desk. Okay, because the invigilators, right, they will monitor your computer screens from behind. So we must be able to see your screen. Okay, then you're working, you do on piece of paper. Right? So, not open book, but you have 4 pieces of cheat sheet or 4 pieces of formula sheets. Can Okay? Yeah, so wait for the announcement. You can go.